use end behavior on this. If I say as x goes to infinity, what does e to the x over x go to? You say infinity. Now, you know that to be true, that because although it's really getting bigger over getting bigger, it goes to infinity because what? Why does it go to infinity, not 0? The top grows faster. Okay, now you just said L'Hopital's rule right there. When you said the top grows faster, you're saying that I need to really figure out which one goes faster. I need to compare their rates of change. Well, that's L'Hopital's rule. To get an indeterminate limit, or I'm not sure what this equals kind of limit, you compare, well, how fast do they go to their limits separately? How does each one approach its limit? L'Hopital's rule then is used to evaluate two indeterminate forms. 0 over 0 is an indeterminate form. Now, indeterminate form means there is an answer, we just have to do more to figure it out, right? Infinity over infinity means there is an answer, we just need to do a little more thinking to figure it out. I think it goes without saying at this point that zeros don't cancel, and this is not 1. And infinities definitely don't cancel, and it's not 1. Infinity is not a number, it's a concept. You say concept, okay, they say concept. A concept, yeah, it's a concept. It'd be like saying democracy over love cancel. That's crazy, they're concepts. Okay, they can't cancel, they're not numbers. This is not numbers here. They don't cancel. It doesn't work that way. All right, so really what you said, e goes way faster. I gave you a table for your learning pleasure over here. Look at, when you get to 1,000, e to the 1,000th power is 1.7 times 10 to the 434th, where x is just a measly 1,000. You can see that e goes way, way, way faster, and that's why the results approach infinitely large, right? Okay, now then L'Hopital's rule is the idea that if you get something getting small and the bottom getting small, then to figure out what the overall limit is, I can compare the rates of change of each. So I could say, well, how fast does the top go to 0? Look at its derivative. How fast does the bottom go to 0? Look at its derivative. Then compare the derivatives. It's cool, but the limit of the derivatives will equal the limit of the original functions. By comparing the rates of change, you get what the limit overall is. The same is true for infinity over infinity. If you get infinity over infinity, you say, well, how fast does the bottom go to infinity? Which means look at the derivative. How fast does the top go to infinity? Look at the derivative and evaluate the limit. Now, it's important not to use L'Hopital when it's not appropriate. By the way, this could also be negative infinity in there anywhere. It's also applicable. Never use L'Hopital unless you get an indeterminate form. All right, if you bust out derivatives on a case where it's not reasonable to do so, you will get the wrong answer. For example, if I were giving you this problem here, hey, what's the limit as x goes to 2 of e to the x over x? Well, what's the limit? E squared over 2. Easy enough, right? But if you start thinking, if you get locked in after today, thinking, oh, L'Hopital's best, I love L'Hopital, I'm going to do L'Hopital every time. What's the derivative here and the derivative there? Well, now, instead of e squared over 2, you're starting to get some wacky answer, something like e squared over 1. Using L'Hopital when it's not appropriate to do so will get you the wrong answer. It's only when the answer's coming out, well, it depends on the rates when you use it. All right, so don't overuse it is my point. Towards the first skill then, the first thing you've got to be able to do, besides how to use it, is when to use it. I want to first talk about proving something is indeterminate before using L'Hopital. And I'm going to show what the College Board or the AP exam would consider proper work. If on a case like this, you just off to the side write, oh, well, there's 0 over 0. Ooh, That's bad. No. Bad work. In fact, write that. That will get you in trouble in my class. In fact, I'll consider that skip on a test. I won't even look at it after that. And on the AP test, you will definitely not get full credit. Good work, or proper work, is to say, if I look at each individual limit in its own compartment, what happens? So the limit as x goes to 0 of x cubed minus x. That goes to 0. And the limit as x goes to 0 of sine of x. That goes to 0. From that, you could say this is indeterminate form. So L'Hopital is okay to use. And you would go ahead with the derivatives, which we'll do in a minute, all right? But for now, I just want to communicate the work of what it looks like to justify L'Hopital's use. You don't just start plowing ahead using L'Hopital. You have to first say, this is an appropriate time to use L'Hopital before it's ever used. Otherwise, it feels like you're just taking derivatives for fun. So, again, look at this case. If I tried to direct substitute in my mind, what is the limit as x goes to infinity? I guess that's not on my mind anymore. What does cosine go to as x goes to infinity? Well, you're right to be kind of confused. What does it go between? It oscillates between -1 and 1, yeah? What about the limit as x goes to infinity of x squared plus 2? Infinity, okay? Now, is this an indeterminate form? -1 to 1, which there is some gray area there, but it's being divided by infinitely large things. Is that an I don't know, or is that an I know? I know. What is the answer? 0, okay? So the point is, not every limit is indeterminate. In fact, most limits aren't. If it's not a case where this is 0 to 0 kind of thing, it's just an answer, well then just give the answer. Don't give me this indeterminate, you take some derivatives kind of stuff, right? So you're going to have to balance this new kind of problem with this old kind of problem. This is an old problem. You've been doing that forever. It's just kind of actually saying, what is each one doing? So for all these, I want you, except this one is done because I already did it up there. For all these, I want you to get into the limits of the pieces and decide either yes, it's indeterminate, or no, it's not indeterminate. And if it's not indeterminate, tell me what it equals. Is it clear what you're doing? Okay. Let's see. Let's see. Okay. Okay, so the first one I got 0 for the upper limit, 32 for the lower limit. Is that indeterminate, or you know the answer? What is the answer? That's not really dark. Let's go. Okay. What about the second one? I got 0 and 0 for the limits, so therefore that is indeterminate. Right? The middle one we scratched. The fourth one, I have visual, so I thought graphically. As you approach the asymptote of pi over 2 from the left, the graph gets positively large. So positive infinity, or huge positives, over pi over 2, is that I don't know, or is that I know? What is it? That's infinity, that's not indeterminate. And the last one I get really large over really large, which is indeterminate. Okay, you follow me. All right? Now, after you've decided or practiced showing yes, it's indeterminate, now let's talk what a problem continuing on with L'Hopital looks like. When you get one of those indeterminates, that's when you use this, all right, now I look at the rates of change. Right? So it goes a little something like this. For a problem like this, you can see that it's going to be 0 over 0. So just pre-reading it, I'm thinking, all right, this is a L'Hopital case. So I'm going to show the work properly. So it doesn't look like I'm just, you can imagine to somebody who hadn't seen L'Hopital, how insane that would look like. Just out of the blue, now it's something totally different. You see how confusing that would be? Okay, so you justify where you're coming from. You're saying this is a case where the top goes to 0 and the bottom goes to 0. And so by L'Hopital, and that's how I'm going to want you to do this, kind of in an abbreviated way. By L'Hopital, the new problem is the limit as x goes to 0 of cosine of x over 1. At the very least, somebody would read it saying, oh, there's something else going on here. By L'Hopital, at the very least, if they didn't remember, they could look it up. But obviously, I will remember, and your graders will remember. What is this equal to then? As x goes to 0, the new, or the ratio of the rates of change approaches 1. So that means that's what they approach. You could say that really means that they both approach 0 in a proportional way. They're both getting closer to 0 at exactly the same pace, and therefore they'll arrive at the exact same answer. All right? So what about the second one? Pre-reading it as natural log, as x goes to infinity, what does natural log go to? Think of the graph. As x goes to infinity, y goes slowly, albeit this does go to infinity. And as x goes to infinity, the square root of x. Now notice I'm calling it the square root of x, the denominator, as if it was its own function. Not 1 over root x, just root x, like it's its own thing. Where does that go to? Infinity. Is that an indeterminate form? It is. And so by L'Hopital, we could say, all right, how fast does each one go to infinity? Compare their derivatives. Natural log goes to infinity at a rate of 1 over x. Root of x goes to infinity at a rate of 1 over 2 root x. Now, technically, that's still indeterminate, but we can clean that up. Isn't that the same as 2 root x over x? Yes? Which is actually like 2 over root x. So as x goes to infinity, this limit approaches. 2 divided by huge is 0. Now that then tells me, that actually tells me which goes faster. Which goes faster, natural log or square root? Square root grows faster. Their graphs are pretty doggone similar, but the square root grows faster than that. All right, that's the kind of work I would like to see. Try the 4 on your own. Showing appropriate work, you must justify that it's indeterminate before you do L'Hopital. How are we doing? Is that ready? For another minute. Actually, let me get the basics of this stuff. Okay, so for the first one, hopefully it was pretty straightforward. It was indeterminate. 0 over 0 is an indeterminate form. And after you take the derivatives, did you get 1 for an answer? Okay, cool. Second one also is indeterminate, and so it is appropriate to use L'Hopital. I have 1 for an answer there too, coincidentally. All right. I guess 0 over 0 does equal 1, right? No, you were supposed to say no to that. Emphatically no. No, the answer is no. Okay? Just kidding. The third one. I get negative infinity for the log and 0 for the denominator. Is that indeterminate? No. What do you get when you divide a huge negative by a small positive? First of all, the sign. Positive divided by a negative is negative. And huge divided by small is even huger. So this is negative infinity. Now notice, if you inappropriately use L'Hopital, I talked a little bit about that over here. So maybe somebody just mindlessly saying, well, there's some zeros and there's some infinities, so I'll just slap L'Hopital without talking about whether they're the right zeros, the right infinities. Well, isn't the derivative that 1 over x over 1? And as x goes to 0, what does this approach? On the positive side, this approaches positive infinity. You can see then that you obviously get the exact wrong conclusion if you just mindlessly slap L'Hopital everywhere. Okay, you must justify and only use it when it's appropriate to do so. Okay. Last but not least, the derivative of inverse sine. It was indeterminate. Were you able to effectively take the derivative of inverse sine of 2x? You bet you were. It is 1 over the square root of 1 minus 2x squared times the inside, which is 2. Did you take the derivative on our sign properly and use the chain rule properly? Yes? Okay. I didn't think about it. Nobody went. You didn't go off to the side and do all that triangle stuff, did you? You're a real overachiever if you did that. Way to go. All right. What about the denominator goes to 1? As x goes to 0, then what does this limit approach? The answer is 2. Okay. Now, who likes buy one get one free? Everybody. See? Well, sometimes you're going to get L'Hopital where you get 2 for the price of 1, or maybe even 3 for the price of 1. So, look at this first one. Actually, let's do this one. Nah, forget it. Let's just go for it. All right. So this guy. Just pre-reading it, it feels like 0 minus 0 over 0. It feels like a L'Hopital case, not a normal limit problem case, so I'm going to go about doing my L'Hopital. First of all, write small and start at the upper left. Okay, if I say the limit as x goes to 0 of sine of x minus x cosine of x, wouldn't you agree that 0 minus 0 times 1, and therefore 0? And the limit as x goes to 0 of x minus sine of x is 0 minus 0, and that's 0. So is this an indeterminate form where it's appropriate to use L'Hopital? It is. And so by L'Hopital, we get the limit as x goes to 0 of the numerator derivative. What is it? Cosine of x. Good warm up. Now we get into the hard part where you have to be careful. Minus x sine of x, negative sine of x? Is that what you're saying? Derivative second? Okay, minus cosine of x, okay? Product rule, being careful with the negative. Do we all agree? And the denominator? 1 minus cosine of x. If I try and, I think you'll agree that the cosine subtract away. If I try and evaluate, the top is 0 and the bottom is 1 minus 1, which is also 0, it's still indeterminate. So do we just say, forget it, we broke math? No, you persevere and you do it again. You say, do I have to show all that goes to 0 stuff again? Yeah, every time you use L'Hopital, you got to show it's justified to do so. So we need to say the limit as x goes to 0 of negative x sine of x is 0, and the limit of x goes to 0 of 1 minus cosine of x is 0. So by L'Hopital again. Sure would. That's not times, that's a negative. Yes, thank you. Okay, good call. Thank you. That would have screwed up my derivative. All right. Still indeterminate, so by L'Hopital again, it's the limit as x goes to 0 of, what's the derivative of x sine of x? X cosine of x plus sine of x. Okay? And the denominator? Sine of x. Can I cancel out those sine of x's? Sure not. That's never do that. Never. So when we direct evaluate or direct substitute, where does the top go to? 0, and the bottom? I wish it was 1. It's not 1. It's 0 again. You're wishful thinking there, baby. And so the limit as x goes to 0 of x cosine of x plus sine of x is 0. The limit as x goes to 0 of sine of x is 0. And therefore, by L'Hopital a third time, again, the limit as x goes to 0 of the numerator derivative. X, negative sine of x, plus cosine of x, that's good, at least that won't be a 0, plus cosine of x, that also not be 0. I think we're out of the woods now with the denominator 0, or denominator derivative, cosine of x. All right, now if we direct substitute, what do we get in the numerator? 0 plus 1 plus 1 is 2, and the denominator is 1. Is 2. All right. So, persevere, and not all of them are 3 times 2. Some of them are just 2. So, try the second one. Okay, so did you get infinity for that? Okay, so it required 2 rounds through, yeah? So the question usually is at this point, at least for people that don't just mindlessly do what they're told, say, do I have to do all that work? I mean, I could have done that problem before you even taught me about L'Hopital using end behavior, right? I mean, didn't we know that one already? With me? On a problem like that, that end behavior is obvious and easy, then you can still use end behavior. But most of these L'Hopital problems are not going to be obvious. They're going to, I mean, nobody's going to look at that and say, oh, by end behavior, first of all, it's not even end behavior. It's x going to infinity is the end behavior, not 0. That's not an end behavior question, nor is that. Many of these problems are not, oh, any moron knows that. These are not no-brainer, obvious end behavior problems, okay? If the end behavior is there, then like that one where it's obvious, go for it. Try the next two, please. I think this is a 1, yeah? On yours? Okay. Try that, please. Did you get -1 for the lower left? Yes? Okay. And the last one? Indeterminate? No, not indeterminate. And so it goes to small, the top, e to negative infinity approaches e to huge 1 over, that's 1 over e to huge numbers, right? Doesn't that go to 0? So the top goes to 0, or small positives. The bottom is huge positives. And so that's not, I don't know, I need to use L'Hopital. That answer is 0. Okay. Don't overuse L'Hopital. Don't use it when it's not appropriate. All right, last but not least, this is a pretty common AP problem in the last couple of years for your response part, C or D. So you've got this integral defined function. G is would be called an integral defined function or an area accumulation. G accumulates area under a curve. All right. They ask you to evaluate this limit, and at that point, people are thinking, "What the heck is going on? This is a mixture of a lot of ideas." But let's get into it. As x approaches 3, G would approach 0 to 3 of f. Right? By direct substitution, if I try direct substitution. Well, that means the area accumulated under f until I get to 3, what does that equal? Assuming those triangles are the same. That equals 0. Positive area and negative area, right? So the top goes to 0. What does the denominator go to? 0. So this is L'Hopital case. You say, all right, I got into it. It feels like L'Hopital. Now I say, all right, now I need to show the workflow. What should I show first? Limit as x goes to 0, infinity, or 3? 3 from below of g of x is, you might not need to explain where you're coming from there, but if you wanted to, you could say this is like the limit as x goes to 3 of the integral or something like that. That's optional. You could just report the answer. The answer to that is 0, right? The limit as x goes to 3 of x squared minus 9 is 0. And therefore, L'Hopital, person reading this, the limit is the same as the limit as x goes to 3 from below of the top derivative. What is g prime? F of x. And what is the denominator derivative? 2x. What is the limit of f as x approaches 3? Negative 3. As x goes to 3, the y of the f graph goes to negative 3. What does the denominator go to? 6 or negative 6? 6, right? It's not negative 3. It's approaching 3 from the left. So as you approach 3, 2x goes to 6, not negative 6, right? And so our answer is negative 1/2. Yay! You with me? Okay, can you do L'Hopital's rule? Cool. Okay. Now then, yesterday with all the test monkey business, I forgot to get 78, or some people turned it in, some people didn't. That's not my fault. If you still have 78, then get it to me today. Okay. We might have time to ask a question or two, but I want you to go over this fun sheet with us. All right. So if you got the fun sheet, that would be the word. Fun sheet on movement. It had 2 papers and a staple, which still makes it a sheet. In my mind, it takes 3 pages to make a packet. It's a fun sheet. See. All right. So, I don't know about you, but I had a dickens of a time starting number 12, and that's because I moved the graph over to words. That sucks. But I think it said the graph has horizontal tangents at time 2 and time 6. It has a point of inflection at time 2. That's really all I needed. I don't know what it said under S. I don't know. Whatever. I don't think I need it. Okay, so let's talk about this and let's focus on quality work and the answer, shall we? What's the velocity at time 6? Given this is position, it is? How do you know? All right, so it didn't say justify, but if you were to justify, then you would say velocity at time 6 is the derivative at time 6, and that is 0, or the slope of s at 6, if you like. It did not say justify, so if you did justify, that's okay. The slope of the tangent at 4 is -1. Okay, great. What's the speed of the particle? What does speed have to do with the slope of the tangent? Absolute value, yeah. The slope of the tangent is the velocity, and speed is the absolute value of velocity, right? So speed is the absolute value of the velocity at time 4, and so that is, okay. C, for what values is the particle moving left? It didn't say justify, but I justified. When is it moving left and why? Left on what interval? Okay, moving left implies velocity is negative. Velocity is negative when this is below the axis or when this is decreasing. Okay, so left on 2 to 6. You could say the endpoints, but really probably it's not moving left or right there. You should probably not have them in there. Left on 2 to 6 because speed is decreasing, because velocity is negative, or speed is decreasing, position is decreasing, or slope is negative, something like that. You with me? All right, cool. What about, for what values is the velocity decreasing? So tell me your thought process here. Make little leaps in logic. Velocity is decreasing if slope is decreasing, okay. All right, velocity is decreasing if acceleration is negative. What does acceleration have to do with the position graph?
Cavity.
Yeah, the position is concave down, and therefore this is on what interval is it concave down? They told you an inflection point, so it's up to 3, so 0 to 3. All right. That's the thought process. E. Speed is decreasing. Speed increasing or decreasing at 1? Decreasing? Decreasing because velocity and acceleration have opposite signs, and we were comparing both slope and concavity, right? It was positive slope but negative concavity, so velocity and acceleration have opposite signs. Yeah? Time equal 4. Decreasing or increasing? Decreasing because velocity is, again, opposite signs, because velocity is negative, acceleration is positive. You with me? Probably should have in there, I really, just be safe on an AP test, depending on where they did their points, you probably should have in the record what the heck you say they are. Velocity is positive, acceleration is negative, and then say their opposite signs, give the evidence that leads to your conclusion. Here, velocity is negative, acceleration is positive, give the evidence. And at time 7, I got increasing because velocity was positive, acceleration is positive, so they have the same sign. Right? How'd that go? Pretty well? Okay, number 1. Number 1 was B. You had to integrate, find constants of integration twice over, yes? C. This one was a bit of a stinker. How far does it travel from time 0 to the time the car stops? Don't we need to find the car stops time? So find stop. How do I find the stop time? And velocity is 0. There are 2 ways to do that. What's one way to do that, given that this is calculator active? Graph the derivative. Okay, so you could graph the derivative, which is s prime, and therefore velocity, and then what would you find on the derivative? The zeros. Okay. What if you graphed s? Then what would you be looking for? The first time there's a horizontal tangent. Find the first horizontal tangent. So you'd probably be looking for a max or a min, yeah? That, probably max because it's going forward, but I can't remember. But that happened at time 4.179. All right, then the question is, how far does the car travel between time 0 and the car stops? Can you just do position at time 4.179? Yeah, no, why not? If you do that, you're assuming the car started at 0. At time 0, is the position 0? No, you're making a huge assumption, and that's disastrous. It's not starting at 0. Okay, so that's no. Instead, distance is the integral of the absolute value of the speed from 0 to 4.179. I had something like 11.273, so I concluded C. Right? 10A. A particle is moving. How did you say? What the heck is going on? Oh, sorry, this is covering my questions. Sorry. There you go. Sorry, I had that in the wrong place. Okay, so what direction, left or right? Left. The AP, it didn't say justify, but let's just practice saying this well. Is it enough to just, on the AP test, if they said justify, would it be enough to say because velocity is negative? You actually have to give evidence. You can't just say velocity is negative. Take my word for it. You would have to say something like left because velocity at 2, which is negative 1.979, is less than 0. You would have to provide evidence of why you say that. It's not a 50-50 shot somebody could do without a calculator. All right, B, find the acceleration at time 2, the velocity. All right, so what is the acceleration at time 2? Is acceleration given? No. So if acceleration is not given, you're doing some calculus from your mind. Even though it's calculator active, do you need to communicate what calculus you did? You did. So the acceleration is, you prime at 2, you must communicate to the person, hey, I took the derivative, or the calculator took the derivative, or estimated derivative. That was negative 2.1189, so you could go 118 or 119. Is the velocity increasing or decreasing? Velocity is decreasing because acceleration is negative, right? Acceleration is the change in the velocity. If the change in velocity is negative, it must be the case that velocity is decreasing. It's tempting to say then the same thing for speed, but speed is not just the acceleration and how acceleration is. How do we talk if speed is increasing or decreasing? We need to refer to both the velocity and the acceleration. Is it moving negatively and moving faster negatively, or positively positively? What did you say for C? Speed is increasing because velocity and acceleration have the same sign. Okay? Oops, too fast. All right. Position. Did you do something like an integral from 0 to 2.5 of velocity? Does that do it? What does that give? That gives change in position. What else do you need besides to know where it is? You need to know, yeah, where did it start and how did it change to get where it ended. That's 3.9912. Greatest distance. Isn't that an EVT problem? You want the max of the x without regard to sign. So absolute extrema at endpoints are critical numbers. Critical numbers are found by finding what? V equals 0, and that was at time equal 1.603 and 2.390. If I need to find x at each of these. Now x at 0 is given, that's 4. Do I need to show the work on how I calculate each of these? Is it in my record already how I calculate position at every time? That does not cut it. That shows how you find position at 2.5. If you think, I already showed you how I find position. No, you didn't. You showed me how you find position at 2.5. For all I know, you find position here some other way. So if you want to save yourself the writing every time, you need to say, generally speaking, person, it's the initial position plus the change in position. You have to show it generally, or else you're going to have to show it every time. You can't just say, I already showed it once. That doesn't do it. A specific example doesn't cover you forever. So you need to say it. If you do that, then you get something like 4.920. X at 2.390 is 3.9, oh man, 20 or 7. And X at 2.5 is 3.9912. So the absolute max position, or absolute max distance, is 4.920. Yay? Oops. And the total distance, is that the integral of v or the absolute value of v? Absolute value of v, also known as the speed. Integrating speed gives you distance, and that is 1.9912. Yay? Okay. This was pretty straightforward. Did you get 5 and 9 for A, or 4? And A, B, B. 5 and 9, A, B, B. And then the last one, I went crazy position was terrible. And you had to integrate log of 3 minus 2. It was a nightmare. So flow off that. Instead, just say velocity is the antiderivative of this. What I really want you to look for, this is a great gotcha problem of Calc 1. People are tempted not to use sub this, and instead they say this is just log of 3 minus t. Is it? No, it's negative log of 3 minus t plus a constant. The constant was a mess. I think if you put in, it's 2, there's a 2 in front also, isn't there? Sorry. So when it's all said and done, 2 log of 3 minus t, and my constant was 5 plus 2 log of 3. Yeah? Okay, the rest of it, I apologize. Don't worry about the position function. You're good now. Okay? Make sure I get this in 78 today. Have a great day.
Mr. Rickman?
Yes.
So